So I wanted to share with you what engineering design was and how to incorporate that within your lessons. So I was just going to show you quickly the PowerPoint that I gave at the STEM Forum in New Orleans in May. And then I will be coming back in July and helping you all brainstorm some ideas for your for adding engineering design into your lessons at the Reed Patrick. So basically what the engineering design process is this cycle, and you may be familiar with this, but just to kind of quickly go over it, basically if you start here at the top with number one, it actually kids start with basically identifying a problem, or you give the students a problem, and then identifying what criteria or constraints may be necessary for the project. Obviously, then they would brainstorm possible solutions. This is really where the collaboration is key with the students. And then coming up with ideas, obviously, exploring those possibilities by testing, selecting what approach they're going to take. They build a model or prototype, and that's really key here. You can do either kids can come up with their own model or prototype, or you could actually have everybody in the class build the same prototype and then from there expand their abilities after they test. And I've done this both ways in the classroom, and it works really well. And then refining their design. I feel like 7 and 8 are the key points for the engineering design process. So actually having the students build something initially and then testing it in here. I feel like that arrow should be labeled test. And then having the opportunity to go back and refine their design. So many teachers don't give students the opportunity to do, and I think that's where a lot of collaboration and creativity come into play. And also really it's really the process of not only engineering design but science as well as that. And I always like to tell teachers when I give this presentation, why should we do this? Why is this so important? And so really it has to do with Bloom's taxonomy. And I really like this revised Bloom's taxonomy that I've been using lately. And it has obviously the remembering, the understanding, and the applying of information here on the bottom, which those are all very valid tools for learning, but really where engineering design comes into play is up here at the top, and this is really what we should be shooting for, is making sure that our students or our kids are creating, evaluating, and analyzing their work. And the reason that I like this Bloom's taxonomy is because this is where the real upper level thinking skills come into play. And also, when you're working in groups and collaborating, these just are so much more rich if we get a lot better creations and students evaluate things from different perspectives and then analyzing the relationships with things with a group, with collaborating with a group. And I think this is where the most bang for the buck really is. So. And why do we do this? I think it's really in kind of triggers those key 21st century learning skills of innovation, solutions, being creative, making decisions, having imagination, and really the inspiration. When I have started really doing this with my students and letting them test something and then retest it and work in groups. I do lots of group work with my students, or did do a lot of group work with my students, but they really were engaged. This is it's nearly 100% engagement of all your students. And so I think that is really important. And the other thing is kids just have fun doing this. And so if we can, the more we can get kids to create and design and test and retest and collaborate, kids are just going to have fun, and that's the whole key. We want them to enjoy science. And the other thing is, it's kind of like that old adage, two heads are better than one. Well, when you get 4 or 3 or 4 kids working together, or sometimes even more, you really start to see the learning take place, and their engagement increases, and it's really quite incredible. So, and you've all, I feel like I'm speaking to the choir, but you've all seen this before. So the other thing that I like about engineering design, and really sort of the problem-based learning that takes place as part of engineering design, is that it integrates all of these different subject areas. So you can, integrate social studies many times within these projects. Obviously, you're going to have language arts skills being applied because you're going to incorporate writing into this as well, and it's just kind of natural to do so. And then technology can definitely be involved with this, health and PE, the arts, careers, math. As far as the arts is concerned, a lot of times I've had my kids actually sketch out their plans, and that alone is just a really good way to involve the arts as well, and easy. That's just easy to incorporate. So all of these things can really be incorporated into engineering design problems. So here are some examples of labs where I actually incorporated the engineering, or not, I guess I didn't do all of these labs, but here are some labs that you can actually use to incorporate the engineering design principles. And some of these I've done, some of these I haven't done. I have seen things like these done, but there's lots of ways to incorporate this within a classroom. Some of these can be big projects that span several days, even maybe a couple weeks if you wanted to do that or had the time. Some of these are small projects, but and then again, a lot of these, I think every one of those could be found online. Actually, I think I've looked all of those up, and you were able to, these are readily available on the internet. And anyway, so those are some ideas of things that you could actually do with different topics. And then here's an example of a lab that I did. And essentially what my students did is they, originally, before I incorporated the engineering design process, they took a coffee filter using a motion sensor probe, and they dropped it, and they recorded, that data, and then I had them drop a folded up coffee filter, and they had to determine which one actually fell more slowly or more quickly, and we talked about air resistance, and they were able to talk about that. So, and yes, they liked the lab, and we did it, and we had fun, and we used the force probes and collected data and graphed our data. But then I decided to add that engineering design piece, and so what I did, just really easily, is told the kids that I wanted them to take their open coffee filter and drop it, but this time they needed to design one that would fall more slowly. So, and the one that was crumpled up, they would take it, and they had to design one that would fall quicker than the original one. So that's where the engineering design process came in. And like I said before, yes, the kids liked the lab when I did the lab originally, but you should have seen how much they loved the lab after I added that engineering design process. And there was so much thought, and they were so into it, and they spent so much time with it that when, I think I gave them a double block period to do the entire lab at that point, from start to finish, and they wanted to do it the next day. They were competing with each other. They would be checking out other groups' data to see what they came up with, and it was just really incredible how much that ignited their passion for learning. So that is that. And that's just going over the engineering design process again, so I think we can skip that slide so I can move on. And then some other, maybe an extension activity or a way to extend that whole dropping the coffee filter lab would be to actually design parachutes for gummy bears or, whatever, egg drops or anything like that, but just trying to get them to design some sort of apparatus that would safely allow something to fall. So that could be a way to actually extend that activity. So, and I did 1 year do egg drops with that, but being pressed for time as a teacher, I only did that 1 year. So it would have been nice if I could have done it more. So anyway, that's really all I wanted to say. So hopefully I didn't take up too much time. I know Darlene and I have mentioned a couple of ways that you could incorporate engineering design easily into the Ruth Patrick Center. And I would love to come back and work with you all in July and help you brainstorm some ideas for that. So anyway, thanks for your time, and I'll talk to you all soon.